So the next type of question that you're going to be asked is to identify whether a table of values is modeling a linear function. Okay? Now, in order for it to be a linear function, what has to happen is that it has to have a constant rate of change. Okay? So if the rate of change is different between any two sort of intervals along the graph or table, okay, then it's not a linear function. Okay? And the way that you're going to test those is you're basically just going to look, is the change of y over the change in x always the same? Okay? And so if you look at a problem like this, you see that the x's, each time you increase your x here, if you look, you're going up by, and again, test to see. So this is up 4, this one's up 3, this one's up 2, this one's up 1 or 2. Again, it doesn't matter if that's consistent there. What you're looking at is going to be the difference of y's between any two intervals over the difference of their corresponding x's. So when we look at the difference between their y's down here, again, here from 10 to negative 26 gives you negative 36. Here from negative 26 to negative 53, you get a And so here, when you look at the difference from 26 to 53, your difference of 27. Okay, here from 53 to 71, you have a difference of 18. Okay, and from negative 71 to negative 89, a difference of, again, 18. Okay, so what you can do here is you can take any of the changes in y's. So if I took sort of these matching pieces here, is this number divided by this number, again, the change in y over the change in x, consistent throughout this whole thing? So is negative 36 over positive 4 equal to the next one, which is negative 27 over positive 3? Is that equal to negative 18 over positive 2 and negative 18 over positive 2? So what we did is we're testing to see, is this consistent? Is the slope always going to be the same? And what do each of these always wind up being? They're all negative 9. Every single one of them is the exact same rate of change. And so this one is a linear function. All right, I want you to test that for the second example, please. See if when you test the difference of the outputs divided by the difference of the corresponding inputs, are they always going to be the exact same thing? Rather than doing all of them across the top and then all across the bottom like I did here, the wiser thing to do is just to do one step at a time. So here, it's a difference of x's of plus 1, a difference of y of plus 4. So you're looking at plus 4 over plus 1. Okay, and we want to test to see, is that the same for the next one? So the next one, we have a x of plus 7 and a y of plus 24. So is 24 over 7 the same as 4 over 1? No. So right away, we know this is not a linear function. And you can stop. Once you find that it doesn't pass, you can stop. If you find that it does pass, just keep moving until you confirm that all of the corresponding cells yield that same rate of change.